Hello everyone, I am Tarun Kaushik, and today in this lecture we will be doing that question which we have left with in the previous lecture. Okay, so we are doing the complex analysis and we have done this much of topics, and today we will be doing that question regarding Cauchy's residue theorem. Though we have done the question based on the residue theorem, but we will be seeing a different type of question in today's lecture. So we will go to that question, and the question was this. Okay, so before doing, you just remember these two things. Cos theta, we can put the cos theta, that is in the polar form. We can put this cos theta into the Cartesian form with this formula, z plus 1 by z divided by 2, and sin theta can be replaced in the Cartesian form with this formula, z minus 1 by z divided by 2i. These are the two important formulas. You just remember these two formulas. Okay, so back to that question. The question was this: 0 to pi integrate this function with the residue theorem, using residue theorem. So we have discussed that we will be putting this value of z as e raised to power I theta, and just to do the differentiation, this becomes dz, and this becomes I theta, and I theta becomes I into d theta, this I into d theta. After doing that, just put the value of cos theta, that is equals to 1 by 2 z plus 1 by z, and after just doing the simplification, we get this formula z square plus 1 divided by 2z. Just simple calculation or doing that LCM, you get this, and after getting, you just put the value of cos theta over here. When you put the value of cos theta over here, after that just do the simple calculation, that is just put the value of cos theta and take the LCM and solve that LCM or fraction part. You just solve. But here one point you need to concern, or you need to take in your mind. The point is, the limits are from 0 to pi, but 0 to pi means this is semicircle, this is 0 to pi, but we are interested in the complete circle. The complete circle means 0 to 2 pi. We are interested in 0 to 2 pi. Our circle should be complete, 0 to 2 pi. So because this e raised to power I theta, because this represents the equation of a circle. Okay, equation of a circle, not a semicircle. It's the equation of a circle, and a circle consists from 0 to 2 pi. Okay, and it is pi, so we will make it to 2 pi. How we can make it? Just multiply that by 2 and divide it by 2. How I did this? I did this using the property of integration, which we have studied in our 12th class. Those who have not studied, we will be studying this in the next upcoming lecture, when we will be studying the calculus. Okay, this is a property of integration. So after doing the multiplication, I divided this by 2, so this becomes 0 to 2 pi. Hence my limits here, this becomes the curve C, where C is the circle of radius 1 unit. This represents, here I just forgot to mention, this is the C, this means C, and where C is mod z equals to 1, this is mod z, which is equals to 1 unit. Okay, this is a 1 unit radius circle, and after doing the simplification, you got this 2 poles, minus 2 plus minus root 3. Here only one root, that is minus 2 plus root 3. This pole, only this pole is lying within the circle, and this minus pole, this minus 2 plus this, only this pole is lying within the circle, and minus 2 minus root 3 is not lying in within the circle or inside the circle. Hence it will not contribute its residue. So we will be calculating the residue on minus 2 plus root 3. Okay, so how you put this value, or how to calculate the residue at this point? It is very simple. You refer to the previous lecture, I think the lecture number 2 of this residue theorem. You just put, how to put z minus alpha, alpha is the location of pole, and just multiply it with the f of z and put the value. After doing the multiplication, you just replace that z by alpha, substitute the value of z by alpha, and solve that. You get this 2 by 3 root 3. Okay, and just multiply this by 2 pi I. When you multiply it, you get your answer, and it was a question asked in the mains 2015. Okay, this was equation asked the mean 2015 for the 10 marks. Okay, now this was a question in mains 2013, similar type of question. Okay, UPSC gives very tricky type of question, not a very simple question. Here again the limits are given from 0 to pi, and we have to make it 2 pi by and divided by 2. I have done it in the next, you can say, next row. So here this is sine 4, so we can make it sine square raised to the power 2, so it becomes sine raised to power 4. And we know that's the value of sine square theta. We have written this value over here. Sine theta is equal to z minus 1 by z divided by 2i. So we substitute this value over here and doing the square of this. So I'm removing it so that it will be easier. I have put this value of the sine theta and doing the, and then this becomes square raised to power 2, it becomes raised to power 4. I do the simple, you can say, but I just put this value. Okay, after that this is the constant, taking it outside and taking the LCM and solving this portion, so this becomes this. After that this becomes, we have to solve it by residue theorem. Okay, so do not just open the bracket with the power 4, do not apply the binomial expansion and solving this. Okay, we have to solve it by residue theorem. Okay, by solving the residue theorem it becomes simple. This shows that the location of pole is at 0 and the radius of the circle is 1 unit. How? Because we have made it from 0 to 2 pi. We have made it from 0 to 2 pi. This implies that the radius of the circle is 1 unit and the pole which is located at 0, this is lying inside the circle. When the pole is lying inside the circle, the residue will be contributed. So there will be contribution of the pole which results in the residue, and how to calculate that residue we have studied in the same lecture and previous lecture too. So just put the value residue at z equals to 0, limit z tends to 0, and this becomes 1 by 4 factorial. Why 1 by 4 factorial? Because here 5 poles are present. How many poles? When 5 poles, so we are required to do the differentiation 1 time less the number of poles present. जितने पोल प्रेजेंट है उससे एक टाइम कम डिफरेंशिएशन करना होता है किसका? फंक्शन का, f of z का. So here the poles are 5 and we will doing the differentiation of the above portion. How many times? 4 times or 8 times, 5 times, 4 times, 1 time less. And the number of time we differentiate, we have to divide by that factorial, by the factorial of that number. So we are dividing it by 4 factorial. Okay, this is the 4 factorial. If you are not visible, I am writing it here. This is the 4 factorial. Okay, so just do the derivative and divide it by 4 factorial. You get your answer. This is 3 by 8 into pi. The answer is 3 divided by 8 into pi. This is the answer. Very easy question for the 10 marks. For 15, oh sorry, so for 15 marks. So the 15 marks that question was asked. Okay, so this was again a question, not a very difficult question. We have studied this question in our previous lecture also. Not this lecture, no sorry, this question we have discussed some separate question. This question meant for the from the Lorentz series, and it's for the 15 marks asked in 2012. Expand this series in the from these 4 terms. These you can say these 4 areas are given where we have to calculate the Lorentz series. So first, what we are required to do, we have to take the partial fraction. We have to separate these. So we have separated this 1 by 2 z divided by z plus 1 minus 1 by 2 z plus 3. These are 2. So when this is the area when mod z is greater than 1 but less than 3, then it means mod z is greater than 1 and mod z is less than 3. This becomes when mod z is greater than 1, then this implies when 1 by mod z will be less than 1 and mod z is less than 3. we have discussed this Lorentz series, how to take the Lorentz series. We have discussed in complete detail in my previous lecture, so we will be not discussing. If you are still having any doubt, then you can put into the comment section. Otherwise we have to move further or proceed further. This was a very good question asked in the UPSC 2015. It was for the 15 marks, and the 2012 it was asked. The question was 0 to 2 pi. Here this 2 pi is already given. Okay, it means the circle is 1 unit. This is the 1 unit, and this cos theta, this is replaced by 1 by 2 z plus 1 by z. Okay, so just put the value and do the simplification. After doing the simplification, you get these two, az minus 1. We have just what we have doing the factor, we have taken the factor into account, okay, into computation. Az minus 1 into z minus a. So this implies z is equal to a and z is equals to 1 by a. Since the value of a square is less than 1, this implies, this is given in the question, a square is less than 1. Since a square is less than 1, this implies a will be less than 1. When a will be less than 1, then a by 1 by a will be direct 101%, it will be greater than 1. When a pole which is lying outside the circle, it will not contribute to the residue, so we will not consider this term z equals to 1 by a. We will not consider this. Only z is equal to a. This pole lies within the circle or inside the circle, hence it will contribute to the residue. And how to calculate the residue of it? Residue at z equal to a is simply limit z tends to a, z minus a into f of z. Just put the value of f of z and do the simplification. This will cancel out, and just put the value of z equals to a. In this, it becomes I divided by a square minus 1. So just multiply this by 2 pi I and we get our answer. Okay, so this was a question again, Lorentz series. This question was asked in the UPSC, I think. I was doing UPSC. I just forgot to put the year, in which year it was asked. The question was f of z equals to 1 by z square with center equal to z equals to 1 and z minus 1 equals this was the question. This was solution line. This was the question. F of z equals to 1 by 1 minus z square with center at z equals to 1. Okay, here center is given. Z equal to 1. At z equal to 1, the center is this at the location of 1. Okay, but it has not mentioned the radius, that how much radius is of 2 unit, 3 unit, 1 unit, half unit. Okay, so we will not bother about that. We will proceed. Just do the partial fraction. We got this. But before doing that, there is a trick of solving such type of question. Whenever you are given that do the or calculate the Lorentz series about z equals to this, z equal to that, z equal to 1, 2, 3, 5, a, anything is given, just take that to that, just take the value towards the left side. That becomes z minus 1 and put z minus 1 equals to t. Okay, after doing it, this will become this z minus 1 become 1, this 1 minus z, this become minus t, so this will become minus 1 by 2t. Okay, and this 1 plus z, we have to make it z minus 1, and we are having z plus 1, so how to make it z plus 1? So just do the addition of minus 1 and plus 1 on it. So take this z minus 1 at one place, and this 1 plus 1 becomes 2, so this becomes z minus 1 becomes t, and this will plus 2, so this lower term, this denominator part will become zt plus 2, so this will become t plus 2. Okay, so this is minus 1 by 2t and this 1 by 2, and we take the 2 common from this point, so this will become 1 plus t by 2, and this when it goes to the numerator part, it will become minus 1. Power will become minus 1, and after that just do the simple expansion. I have told you about this expansion. You remember these three important: 1 plus x raised to the power minus 1. I am writing for the sake of better understanding. This 1 plus x raised to power minus x when you are getting minus this, okay, and e raised to the power x. You remember this simple and very important expansion. These 3 or 4 are very important expansion, okay. So that's all for this question. Now we will proceed further. This was again a question asked on the simple definition of the complex analysis, that is analytic function, that we have to prove with harmony function, that we are required to calculate this imaginary. This is the imaginary which was asked in the question, and this is the real part which was given. This real is given and the imaginary is asked, and this f of z, this analytic function af, this analytic function was asked to calculate, okay. So we can calculate it now. And these slides or these you can say PPT of this complete lecture series is available on the Google Drive. I will be posting that or you can see that link of this PPT in the description below, okay. So this was the complete solution of this question, and we will studying a different type of question now. This was a question related to the integration, that complex integration, okay. The question is z minus z square into dz, and we have to integrate this function over the curve C, where C curve is the upper half of the circle, okay, upper half of the circle. And by you can say that by default we measure the angle from anti-clockwise direction, we in this direction, okay. This is the 0 and this is the pi, okay. So we will be making this so our limit will be, by default our limits will be from 0 to pi. These are our limits from 0 to pi, and in the polar form the z is replaced, or z can be put equal to r e raised to power I theta, okay. Here mod z equals to 1. This implies that the radius of the circle is 1 unit, okay. So this will become z equals to e raised to the power I theta. Just replace this z by I raised to power I theta and just the simple derivative, okay. When you do the simple integration, sorry, this was a question related to the integration, just do the simple integration. After doing it you get this 2 by 3 again, okay. In the next part we are required to do the same integration, but in this time we are required to integrate it in the from pi to 2 pi, and when we integrate it from pi to 2 pi, or in the portion, or you can say we will be taking it from the anti-clockwise direction or lower half circle, then the limits will be from 0 to 2 pi. Limits will be this in the lower LOWR, lower half of the circle. Limits will be changed. Limits will be from pi to 2 pi. After doing it, just simple integration you can do it, and you get the answer from minus 2 by 3. That is the simple answer, that is the answer, okay. And again very simple question, you can do it. 1 by z, you get minus, we have to show it, 1 by, when we integrate 1 by z over dz, this when we take it from 0 minus 1 to 1, these are two limits here, minus 1 to plus 1. When we move it from this point to this point, we get minus pi I, and we move to this side, we get pi into I. This was the question, okay. Just you can do it, and if you cannot or you face any problem, then you can put into the comment section. I will be happy to reply that, okay. So this very simple question asked in the UPSC, no, not asked in the UPSC, but this was a question, I have specially done it. This was a question, very simple question but very tricky question, and it can be asked in the UPSC mains 2016. Chances are very high. The question is the function this e raised to 3z square plus 7z plus 1 divided by z minus alpha into dz. This was the question asked, and the circle here, the curve C, this curve is a circle, this is a circle where x square plus y square is equals to 4. It means the radius is 2 unit, and we have to find out the value of f of 3. We have to calculate the first derivative at 1 minus I and calculate the value of double derivative of 1 minus I. So we assume this function at phi of alpha or phi of z or phi of alpha. So this become phi of alpha, this become 3 alpha square plus 7 alpha plus 1. We have to calculate the value of f of 3. Since this is 3, alpha is given as 3, and the location of this circle, or you can say radius, is 2 unit, and 3 will be somewhere at here. So this pole is located outside the circle. The pole is outside, pole is out, and pole is out, the value is 0, so we put it at 0. Okay, understood? Now in the next case, f of alpha, the complete f of alpha will be 2 pi I into phi of alpha, and we can calculate this phi of alpha, but we are required to calculate the value of first derivative, and this is the alpha, this is the phi of alpha. We can calculate the first derivative, and we have solved it into the next page. This phi of alpha will be 2 pi I into 6 alpha plus 7. Just do the simple derivative, again doing the second derivative, this will become 2 pi I. So it is independent of alpha, and it will be same for all values of alpha. Since it is independent of alpha, so it will be constant term. Okay, but phi of first derivative of this alpha will be 2 pi I into 6 alpha plus 7. Now put the value of alpha, that is 1 minus I, over here, and do the calculation. You get this answer. Okay, now a different type of question again. In this, the real function, this f of z u plus iv is analytic function, and u minus v is given this. Okay, u minus v is given. So for this type of question, you are not given u, you are not given v, you are given the combination of both real and imaginary. So in this case, you are required to calculate the complete analytic function. Though you have given the combination, you don't have the single real function or single imaginary function. In the previous question, we have seen that the question was consist of only that imaginary part or only the real part, but it's a combination of both real as well as imaginary. So how to proceed for this question? This f of z can be written as u plus iv, and this function can be written as just doing the multiplication by iota in the both side, here and here. When you do the multiplication, it will become f of z plus I into f of z, and this become u plus iv minus v. This become like this. Just doing that, taking real part at this place, this side, and taking the imaginary part over this side. When you take this become f of z plus equals to u plus iv. This is capital U, and this is capital V, and this is capital U, and this is capital F of z. So this capital U belongs to u minus v, and v belongs to u plus v, and we are given this u minus v. It means we are given the real function, that is u. Okay, after taking it u, the real function is given. Just do the derivative with respect to x and with respect to y, and my main motto of making the lecture is only to help you regarding the simplification of the question, that how to solve the question with very simple procedure. Okay, my main motto is the simple process, simplest procedure, which you have to, which will live in your mind for the maximum time. Okay, that is my primary motto. I'm giving simple tricks how to remember the things for a long time. Okay, so in this type of equation, just do the derivative with respect to x and with respect to y. जो भी फंक्शन दिख जाता है उसका x और y दोनों के रिस्पेक्ट में सिंपल डिफरेंशिएशन कर दो. आफ्टर दैट you just put the value f of z equals to u plus iv and do the derivative of this function. This become f dash z, and this become del u upon del x. This become this, and del v upon del x. And now after doing it, just replace x by z and y by 0. Just put the value of y equal to 0, and it will become very simple question like this and like this. This will get cancelled out, and this will get cancelled out. You got this. After doing this, you just do the simple integration, and after doing the integration you got your answer, this z minus 1 plus I into cot of z plus 2. This was the question asked, not asked, I think asked, it was a question asked. I again forgot to mention the year and for the how much marks. I think this was in 2013, and for the 15 marks. Thank you for watching this video, and please do subscribe and like these videos and share these videos, so that as much as you can share, so many person or many candidates like you will get benefited, those who cannot afford. Okay, so again, thank you for watching these videos.